Polynomial Inequalities, Lesson 3-3. So we are going to take some time learning how to work these type of problems out, but let me give you a sample of exactly why we will be doing what we're doing. So if you could just watch along as I explain to you what exactly is our task today. There's no need for you to draw what I'm drawing out right now. Let's see. So let's take this being our x and y axis. This is our x and this is our y axis. And we have a given polynomial graph, and this is me randomly making a polynomial, sketching one that is. So let's say this was the polynomial that I sketched. Okay. Now, I know that the graph didn't necessarily touch there, but let's pretend that it did. And so you'll notice right here, we have an x-intercept, we have an x-intercept, and let's pretend that it bounced right off of that x-axis. There's an x-intercept. It crossed the y-axis. This is a y-intercept. So this polynomial, first of all, we can go ahead and assess the fact that it is going to be an even graph. Why? Well, if we look at the end behavior, both arrows are paired up, pointing in the same direction, so we know it's an even function. We have 3 x-intercepts and a y-intercept, but if you recall, each one of these x-intercepts has what's called a multiplicity. So the behavior of these x-intercepts has a value that we attribute it to a multiplicity. So for instance, that x-intercept would have a multiplicity of a 1 because the graph goes right through that x-intercept. The same thing goes for this one right here. It also has a multiplicity of 1. But if you look at this point right here, the graph bounces off the x-axis, so it's going to have a multiplicity of 2, or basically an even multiplicity. So 2, 4, 6, 8, 10, 12, but we're just going to assume it's a 2. Okay? So if you notice, just for an example here, if you add those multiplicities of 1 plus 1 plus 2, it just so happens that it has a degree of 4. Anytime you add multiplicities, that tells you what the degree of your polynomial is going to be. Recall that the degree of a polynomial will always be your highest exponent in standard form, okay, or in factored form. So it does go to say, and it verifies the fact that we said our graph was even, right? So our degree was that of an even graph. So what's going to happen, though, is I'm going to ask you guys, where is your graph above or below the x-axis? Above means greater than 0, and below means less than 0. So what's going to happen is I'm going to give you a graph function, and I'm going to ask you, where is it above 0 or above and equal to 0? That means greater than or equal to 0 means above. Is the graph sitting above the graph? Where? If I say graph is less than 0 or less than or equal to 0, I'm asking where is the graph falling below the x-axis. So both of these has to do with the x-axis. Okay, so here's what I mean by this. So let me see if I can move what I just wrote here a little bit lower. And let's pull it down here out of the way. Okay, so let's talk about above the x-axis. So I'm going to take my yellow highlighter and I'm going to trace. So I'm starting right over here, and above, this piece is definitely above the x-axis, right? So I'm going to highlight that. This piece right here is not, this purple piece. It falls below the x-axis. Let's go back here. This is above. It's still above the x-axis. It's still above, 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 above. Okay? So notice that your frame of reference is this x-axis here, okay? Above the ruler, let me get this straightened out here at the 0. So above this x-axis is yellow, below my ruler is purple. So again, yellow is above. That would be greater than or equal to 0. And purple was less than equal to 0 or less than, that's below. So you are going to identify the regions for me, and I'm going to show you how to do that. So let's start by doing a few problems. We're going to aim and do like 3, okay? So here's problem number 1. I'm giving you a sign chart to help you graph. I'm not drawing out the y-axis on this. I'm only giving you the x-axis. So pretend that you know that you can visualize the y-axis, even though it's of no importance to us right now. So let's start working this out. First of all, we need to find the x-intercepts. So let's find the x-intercepts. So I'm writing a little bit lower than my graph, my number line here, because eventually we're going to draw on that number line. Take your factors, so in this case x plus 3, and set it equal to 0 and solve. So I'm going to subtract 3 on both sides. Here is my very first x-intercept. I'm going to go over here on the x-axis and plot my first x-intercept. And then, goodness gracious, let's do that again. So here's my x equals negative 3. And then I have another factor. So let me just slowly line it here. 6x plus 6. I'm going to set it equal to 0. Subtract 6. So 0 minus 6 is negative 6. Divide by 6. So x is negative 1. Here's my next x-intercept. And I'm going to put the dot right here. Okay. There you go. Now, I want you to recognize that our graphs here have factor powers, and the factor powers occur as exponents. These are our factor powers, okay? If I look on problem number 4, that's a power, that's a power. If I look at problem number 5, that's a power. So if you're saying, okay, she's circling exponents, yes. Each factor has an exponent attached to it. We call it the power. Those powers are our multiplicities. So for instance, right now, this multiplicity here for x plus 3 is a 1. And the power or the multiplicity for 6x plus 6 is a 1. Okay? So when I ask you to find the degree of our polynomial, I will need you to add your multiplicities, which are your powers, okay? So in our case, 1 plus 1, let's make this pen a little bit thicker, 1 plus 1, our degree is a 2. And because it is an even number, so I'm going to put therefore, these 3 dots means therefore, it has to be even. So we have to decide whether our arrows are going to be both facing upwards or, oh my goodness, it keeps correcting me, or if they're both facing downward. So how do we determine up or downward facing behavior? So what you're going to do is you have to resort to using the leading coefficient. So we're going to do leading coefficient. My leading coefficient is my a value of my factored form. My a value is right here in front of my factors. And in this case, my a value is going to be the invisible number 1. Okay? So since my LC is a 1, and that 1 is greater than 0, I know then that my arrows have to be pointing in an opposite direction because it is greater than 0. So I know the ends are going to be both pointing upwards. So what does that do for our sign chart? So what I'm going to do is I know above my left arrow, my graph has to point upwards somehow. And when I finish touching the second x-intercept, eventually I'm going to have to end up also going up because they both form an even graph of end behavior where the arrows are pointing in the same direction. So recall multiplicity helps us determine what is happening at our x-intercept. This multiplicity here is a 1, and this multiplicity here is also a 1. So what does that mean? That means our graph, when we graph it, has to go through that x-intercept like a line. So here we will do that. It starts here on the left. I approach the x-intercept to touch it. I have to go straight through it. Okay? And then eventually I know I have to come up because I have to go through the next x. And this x also has a multiplicity of 1, so I just have to go straight through it. And I'm done. There is your graph, right? Now, what does that mean in the context of our problem? Well, this is what you're going to do. In Delta Math, you will be clicking, all right? You have to identify if the regions are above or below the x-axis. Well, from -5, from this side here, from this side here that I am kind of signaling here, that side here, the graph is all up. It's above the x-axis. So I'm going to put a plus. Then from -3 to -1, it fell below. So I'm going to say this region in between those two numbers is negative. And then to the right of -1, notice it goes positive. Okay? So why am I labeling the regions positive, negative, positive, negative? Well, because notice in our problem, they ask, where is your graph less than 0? And the only place it's going to be less than 0, I have identified it as here, in between these two numbers. So when you write the answer out to this problem, you're going to say, well, it started on -3, and it kept being purple until -1. And this will be the solution to your inequality. -3 to -1, and both parentheses. And the reason you're going to use parentheses, please notice that you have a less than symbol. You don't have less than or equal to. Okay? So let's try another one. Let's come over here. Let's do number 2. So number 2 has an x minus 8. So we're going to set that equal to 0 and get x to be a positive 8. So let's go put a positive 8 at this dot. And then we have a 5x plus 5, set it equal to 0. 5x is equal to -5, and x is going to be -1. So x-intercept, x-intercept, and let's go to -1, way over here. Okay, so let us determine what's happening in our regions. Well, first of all, let's determine our end behavior. So what's my end behavior? So I'm going to put end behavior is determined by first asking for your degree. So my degree is found by adding the multiplicities. So degree is equal to 2 plus 3. And that gives us a 5. So that means it's odd, right? And when it's an odd function, we're either going to have both facing up, sorry, not both facing up, one facing up, one facing down, or one facing down, one facing up. So I have to decide which one of those two is the one I'm going to select. Well, because my degree is 5, it eliminated 2 of the 4 options for end behavior. But now I need to use the leading coefficient, and I'm going to change color here on purpose. The leading coefficient, what is it? That will help us determine these two. Well, the leading coefficient is here as an invisible 1, and the invisible 1 is definitely greater than 0. That implies it to be positive. So since it's positive, that means my right arrow in odd behavior is the one that I'm going to circle, because you need to focus on right arrow here. The right arrow on this odd points down. The right arrow on this odd points up. So this is the reason why we're choosing this one. Okay? So based on my circled answer here for ends, one goes down, one goes up. So let's go do that sketch. The ends says that one's going down on the left side. So my left dot is this one, so it has to go down. So I'm going to put a downward motion here. And on the right side, it's definitely going up. So let's put another up here. What is happening in between? Well, at -1, we had a multiplicity of what? Well, 5x plus 5 turned into x equals -1. That means that our multiplicity was a 3. So I'm going to put an m equals 3 here to kind of give you a visual. What was the other one? The other one here, the multiplicity was a 2. So 3 means curve through, and 2 means bounce. So let's go do it. Start with the left. M3 says curve through me. So I'm going to go, 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 go. Let me scoot this over, actually, because it's a little bit too much on the right. So we're facing down on this side. So we're going to go through -1, and it has a multiplicity of 3. So I'm going to pretend I'm going to curve, like I'm going to make a U-shaped graph, but I'm not really. Okay, I'm going to curve against it. But then I'm going to say I'm actually going to go up. And do I just go up to come down? Well, at at x-intercept equals 8, the m is 2. And 2 means bounce. So I'm going to keep going, and I'm going to get to this bouncing area. And there we go. There's your graph. So where are we? So to the left of -1, let us use this color. To the left of -1, it's below the x-axis. Between -1 and 8, it's above the x-axis. And to the right of 8, it's above the x-axis. Okay? What do we need in our problem? Let us use, how about orange? Our problem is asking for greater than or equal to 0. Greater than or equal to 0 means above. So I'm going to highlight all my above graph. Here we go. So that's the answer you're going to give me. It's greater than or equal to. So since it's equal to, we go from left to right. The furthest most left is a -1. And we went all the way to 8. And since it's an equal to problem, you can do it like this. -1 to 8. And then union, not that type of union, 8 all the way to positive infinity. And then this would be your answer. So let me say something though. Since it's an equal symbol, that means all of these here, all these were allowed, all allowed, the dot was allowed, all those were allowed. Okay, and because all those are allowed, you can also have said something to the effect of The answer is -8, comma, infinity. So this too could be a finalized answer. The only difference I'd say to you, remember that if you don't have an equal sign, no equal sign requires you to use parentheses on your numerical values. All right, one more to go. Let us do, by the way, I want to eliminate number 8 from your note-taking guide, from number 9. Let's remove number 10. I won't give you those type of problems. Let's remove 7. Okay, let us try this one. All right, let's do number 5. So let me kind of make this bigger here. All right, number 5, we have 8x squared. Let's choose a different color. We have 8x squared set equal to 0. So that's going to be x equals 0. Anytime you have a coefficient times an exponent, not an exponent, and a coefficient times an x value, when you go solving, like, see, watch, 8x squared equals 0, you're going to divide by 8, but 0 divided by 8 is still 0, and then you have the square root, still going to be 0. So just those GCF values are definitely, just set them equal to 0. So ignore the background music. So here's my 0. And then let's do 4x plus 8. And set it equal to 0. We're going to subtract 8 and divide by 2. Divide by 4, sorry. So here's my next x. And I'm going to put a dot at -2. Do you notice how these are just pretty straightforward? I hope so. So degrees, add the multiplicities, and you get a 4. And 4 means even function. All right? Either both up or both down. Okay? It's not going to be opposite in directions because this one's an even graph. So LC is going to determine whether I keep the upward facing ones or the downward facing ones. So what is our LC? Our LC is right here at the front with the x squared. It is a positive 8. So since our LC is greater than 0, we know that your answer has to be both facing up. So far, so good? All right. Let us write out our multiplicities. So at -2, this is the one that came from this one, right? At -2, we had a multiplicity of 2. So I'm going to write m equals 2 right here. And then this one had a multiplicity of 2 as well. So we're going to have 2 bounces, right? Now, our arrows are both pointing upwards. So I'm going to put an arrow over here and an arrow over here. Okay. And let's come towards those x-intercepts. And what are we going to do? We have to bounce when we touch them. So bounce, go up, come back down, need a bounce, and there's my graph. Okay, so what is happening to this graph when I ask what is happening to the left of this ruler, -2 to the left? Well, my graph is above the x-axis, so this is going to be a plus. Well, how about in between -2 and 0? Well, my graph is also saying I'm plus. How about to the right of the 0? It's also going to be plus. So when they ask you in this particular picture, hold on one second. There we go. They're asking you where Is it greater than or equal to 0? Well, all this is greater than 0, equal to 0, this and this. All of it is greater than or equal to 0. So in essence, what you're doing is you're going from negative infinity all the way to negative 2, from negative 2 to 0, from 0 to positive infinity. So the entire time it remains above the x-axis. Now, some students I've seen do this. They go and write negative infinity all the way to negative 2, and they go union, and then they go negative 2 to 0, union, and then 0 to positive infinity, and then close off with the parentheses. That also is acceptable, but it's not necessary. The only time it would truly be necessary is if this symbol right here had not been here, that equal to, and that would mean that you would have to make parentheses right here for all these numbers because you can't include them. And then that whole thing you would have had to write again, but with parentheses here. Okay, but when it's equal to, it's telling you to include those x-intercepts. So the graph was entirely above the x-axis the entire time. So this is just easier to write. All right, I hope this helps. Thanks for watching.